Welcome to the Troxel Podcast. I'm Evan Troxel. In this episode, I have a fascinating conversation with Scott Davidson about the incredible origin story of Rhino. He has been at McNeil & Associates for more than 2 decades now, so I think he knows a thing or two, and I invited him back onto the podcast to tell us all about it. What began as a simple AutoCAD plugin in the early 90s evolved into something much bigger through an unexpected series of events. Scott shares the surprising story behind how Rhino got its name, its journey from industrial design to architecture, and how an accidental leak helped shape the software industry. We also discuss how some of architecture's biggest names, including Frank Gehry, discovered and adopted Rhino early on, leading to its widespread use in complex geometric design and digital fabrication today. Real quick, before we get into today's conversation, I would very much appreciate your support by subscribing to the show wherever you watch or listen, and please leave a review on Apple Podcasts or Spotify. It really does help the show. This was a great conversation with Scott, and as usual, there's an extensive amount of additional information in the show notes, so please be sure to check that out. I recently posted on LinkedIn asking for love letters to Rhino, and the responses were way too much to read here on the podcast. So definitely follow that link in the show notes so that you can read up and, I hope, contribute to it as well. You can find all the links in your podcast app if you're a paid member of Troxel Plus, or you can find them over at the website, which is trxl.co. All right, it's time to crack open your favorite beverages, find comfortable seats around the campfire, settle in, and enjoy listening to Scott Davidson tell the Rhino story.
Yeah. We have a lot of new people. We're dealing with retirement a lot. Now that we've been in business for so long, people are getting old.
That is the beginning of the podcast right there. We found the entry. We found the entry into the Rhino story right there. That's going to be great.
Yeah, great.
You don't feel old. You guys are doing amazing work, cutting edge work.
Thanks. Yeah. I always say, we can do in 30 years what most companies only promise in 3. So
it must be nice. You guys have some luxuries in that regard, maybe, or maybe you don't see it that way. I don't know.
No. No, it's good. It's fun. It's a challenge every day. And I've been doing this for a long time, and a lot of us have. And I have to tell you, it still feels fresh because we just constantly trying to just solve customers' problems. And so it doesn't, the nice part is it doesn't get any more complex than that. And there's never a shortage. There's never a shortage of problems to solve.
And you have this, obviously you have an amazing community. You have an amazing relationship with your customer base. And I think we'll get into all of that. But, your forum is an amazingly, I could use all the adjectives I could come up with. It's incredible. It's supportive. There's a lot of back and forth. There's a lot of there's some heat in there sometimes for sure.
Oh, yeah.
Right. But it's driven by passion, and it's driven by high standards and expectations because you guys have delivered for so long. And so you, like you said, you have no shortage of things to go off of. And that's a place that's just got an amazing collection of individuals who are constantly pushing in there.
Yep. And our structure, we've had to make a lot of choices over the years to keep our structure enough so that we could make sure everybody has a hand in that and make sure everybody can get to that forum. And it means the company has to fundamentally be set up different in order to allow that interaction.
Yeah.
But
I think customers truly feel like they have a voice. And so, let's go back to 1992. Let's go pre-internet. It's not really pre-internet, right? But it's pre-World Wide Web, right?
It's definitely like bulletin board kind of. Yeah, right. Individual servers sitting in people's, you have to know which modem to call to get in. That's right.
Right,
That's
right.
right.
And, I
That's
mean,
right.
it even takes me back to like those old school AOL chat rooms. Like there were definitely 3D chat rooms on AOL back then, right?
Oh yeah.
Yeah,
Yeah.
that
And there
was kind
was,
of my introduction to it all.
yeah. And we had some for Rhino, or what was thought of to be Rhino at that point in time, even though we didn't know if that's what it was going to be.
Yeah,
So I don't know. I've told you that story, haven't I?
I don't think so.
Oh, well, so we were an AutoCAD dealer, and did some plugins for AutoCAD, and in Seattle there was an old Boeing NURBS mathematicians group that contracted with a lot of different PhDs and things around the world, GE, Toyota, whatever. And they kind of got tired of talking to other PhDs, and they wanted to mass market their NURBS library. And so they looked up in the yellow pages at that point in time, found the closest AutoCAD dealer developer, which happened to be us, and kind of said, hey, do you think you put our NURBS library in AutoCAD? And we had a bunch of other plugins for AutoCAD that we sold. And we're like, yeah, we can take a look and we can try, see what's going on. And so we kind of started to push it in there, and doing AutoCAD, I think it was 20, maybe 14, maybe AutoCAD 14. It's hard. It's hard to do 3D in AutoCAD 14.
I remember the 3D face command.
Yeah, exactly. I mean, yeah, well, they had some of those things, but then, just the interface was always kind of set up for 2D. And so, we always have this thing, and we still do, is where, we try to do a little command that just works, and then we try to get it to the customers as fast as we can, like that week. And then, we get feedback, and we kind of work with the customers on a way of trying to develop a feature as opposed to try to spec it or something like that. We just kind of work through it that way. But that, can take a lot of rewriting and things like that. And that was really hard to do in AutoCAD. And so we wrote this little test harness, this little Windows test harness that had 4 viewports and a command line. And so internally we could write, and it could, navigate in 3D. We could write the command, like, what does this feel like? What does that feel like? And then when we kind of got it right, then we'd put it in AutoCAD. Well, that got leaked out to these customers, so we started saying, hey, why don't you just try this little test harness so you can try this out really quick. And then eventually we'll get in AutoCAD, maybe in a month or 2 or whatever.
This was an intentional leak that got out of.
It was just the easiest way. So one of our people was working internally. It's like, hey, today I have it in this little test harness. It's going to take me 3 days to get it in an AutoCAD version. Why don't you I'll just send this to you, right?
How did that happen back then? How did you send stuff around?
You had an FTP site, and right, hopefully you could give them a link. If not, you had to say log in here, and
right,
it was harder. So, but what started to happen was, over time, is that people would say, hey, yeah, that feels right, that's really cool, that's really great. And then so we'd drop it in AutoCAD, and nobody said a word.
Why?
Well, because
the silence is deafening.
Silence is deafening because nobody cared, because they already had it in the test harness.
Oh,
so whatever work they were trying to do,
interesting.
They were
already doing it.
They were already doing it, and
okay.
We're a little slow over here, but it was like thinking. Yeah, I was like, we were like thinking, this is kind of interesting.
Yeah.
So 100,000 beta testers later, we decided that, what, this is feeling like a product, right? And the AutoCAD plugin never actually got released. Wow. And so, then we get into the you want to know how much it's community participation. Then the question is, what are we going to name this thing? We're going to call it Solid this, or Accu that, or Exact this, or Precision that, or whatever.
I mean, it should have been Cyber something back then, right?
Yeah. Cyber something. All these different things. And it's always two words, right? Slammed together. And in the end, it was actually called Rhino from the very, very beginning, as that was just the name somebody had given it off a postcard on their wall when they were putting the framework together in the first place. They're like, no, just keep it. I mean, ultimately, after a bunch of debate, just keep it Rhino. Just keep it
that
Rhinoceros.
was like the internal code name, the development name that you were just using, and then you're
That's correct.
Yeah, why mess with it?
Well, and then we figured out, what's cool about Rhino is that it translates into all languages as Rhino, pretty much all languages, as Rhinoceros.
Nice.
And and we thought we'd get so much trouble for not being professional enough, and that didn't happen. I mean, any more than we get in trouble for not being professional enough in general, but yeah. So that's how we ended up with Rhino, and so it was really the community convincing us that it was a product. Was really how it started.
So what year was the first release? What are we talking about here?
96.
Okay.
So I think we were in the first release about then. Did a SIGGRAPH, and that was kind of the rollout. And so that was right.
So I think it was SIGGRAPH that I first saw you guys, and it was probably you and Bob at a folding card table, kind of a folding table, which was still pretty common for a 10 by 10 booth. Mm-hmm. And I think I was there to see like Electric Image and Form Z, and everybody had booths back then. Everybody had booths. Right, and you guys had, a 4 viewport, PC, and you had like a car fender modeled. So you were showing off the NURBS capabilities, and you even had like the zebra pattern on it, so you could check the tangencies and see how the surfaces were flowing together. Mm-hmm. And I was not interested, Scott. Architect here. I stopped and I looked. I'm like, oh, that's nice, And I'm like, drawing walls and putting doors in them and stuff, right?
Sure.
So I am curious to hear how you've taken over the hearts and minds of so many architects, because I'm sure that was a process. But you didn't start there. I mean, right? You
not
started
even close. It was really marine. We're in Seattle, right? So there's a lot of marine people, and boat hulls are hard. They're complex in shape, and you can't just fake it. They can't be an arc. They can't be multiple arcs tagged together, right? The water knows the difference. And so that's one area that we did. And then the other one is industrial design. A lot of industrial design work where the form, on the exterior form, is really critical to what they're trying to communicate, mm-hmm. or how you interact with it. And so those were the two markets that we started with.
And that's very surface-based modeling, right? I mean, you're talking mm-hmm. about a NURBS modeler. Did you do any solids in the beginning? Was it only surfaces?
We always had the ability to join them together. So it was, yeah.
But it's a little convoluted. It was difficult to do that. It wasn't like...
It still is.
You had to be really good at like matching up those edges.
Yeah, and you still do. I mean, if you think about the interfaces for multiple CAD products, some only allow you to have a solid every step of the way. Mm-hmm. And if you mm-hmm. ever to break it, mm-hmm. they just don't, that step doesn't work, right? You have to modify it to get it to work at that time.
Right.
And, for us, you can compound your problems one on top of the other until you get to the end. But, there's a lot of geometry kernels that demand a certain level of tolerant modeling and, limited within what they can generate. And Rhino's not like that. Rhino's, because we write our own, it's our own NURBS kernel. We can allow tolerances to get big. We can read stuff in that isn't solid. We can read stuff in that's not valid, actually, mathematically not valid, and do something with it. But that's actually, we think, one of our strengths, even though in terms of for instance, passing these models around, you can create models that won't go, to a solids modeler because it's not tolerant enough.
Yeah.
And so, there's kind of a trade-off there. How are you flexible enough but still, to be able to do a lot of things quickly and fast and in the design process and things like that, yet be accurate enough to fabricate from, ultimately, to be as accurate as the machines you're manufacturing with. And that's a real balance there. And we just we're in kind of a different kind of spot there. I mean, it's one of the reasons architects like us is because when you create something from a design perspective, ultimately you can get that to fabrication with accurate enough information to actually drive the machines.
Right.
And so I would say that initially in the 90s, there wasn't a lot of digital fabrication on an architectural scale. That's something go ahead.
I was just going to say, but this really is driven from your early mechanical CAD days, right? Like that mechanical CAD transitioned to CNC at some point, like lasers and CNC, laser cutting and CNC and all those things. But like other large 3D modeling platforms for much bigger scales with much larger, like we're not talking about really close tolerances with architectural modeling anyway, right? Because construction, like it's great if you're within an inch. It's great if you're within a quarter inch, but you're talking about way smaller tolerances, jewelry design, marine design, industrial design, all of these things. And coming from your CAD roots, I mean, that had to be a big reason for that, right?
Yeah. That was the reason that we had that accuracy. But part of the reason we have that accuracy too is that it was an area that we felt like there was a hole in the market. Mm-hmm. Like it was, it's easy to make a mesh model. It's easy to make a 2D model. But there wasn't a lot of tools that were accessible. Like you said, there's, older CAD products that have been around for a long, long time, but that was maybe affordable, that was easy to use, that could work on regular hardware, that still had that accuracy to be able to machine from. And even at the earliest time, that was something that we still pride ourselves on, but that's something that was really important. Now, what was fortunate for us is that we were growing up in the time of the development of those tools on a larger scale. So, one of the first ones we see 5-axis CNC machines that are 12 feet wide and 60 feet long, and then processes to be able to machine those big shapes. So, of course, in the marine industry, that takes over in a lot of ways. Or like you're saying, plasma cutters, that are larger and larger and larger. And then that started to affect architecture. So you get to some of the pioneers like Frank Gehry. And Frank Gehry's doing a lot of shapes that don't make sense in 2D. You just can't draw them in 2D. You have to have all the 3D coordinates in space. And they're trying to figure all that out. And they're using CATIA. And they're using all these tools, the only thing they had available at that time. And actually it's funny, we didn't start in architecture, but one of the very first copies we sold was to Frank Gehry's personal credit card. And we're like, yeah, that's great. And then we're thinking, oh, that's like the whole market. Because at that time,
no one was building buildings like that.
Nobody was doing it.
Right.
And we'd go to SIGGRAPH. We talked about SIGGRAPH earlier, right? We'd go to SIGGRAPH and say, hey, Frank Gehry bought it. And architects would look at you and said, yeah, but I'm not Frank Gehry, right?
Right.
It doesn't I'm not going to do things like that. But what's happened over the years is more fabricators can work digitally. What's happened over the years is there actually are more and more companies, architectural companies that are creating those kinds of shapes and successfully. And we essentially kind of have grown up in that. That's actually, this is a generational thing, right? So you got to wait for the technology to kind of mature.
Right.
And so, and it's, you mentioned, 1 inch. We have companies now that, like, if their concrete person isn't using digital technology to make sure that it's within 1/16 of an inch, that's 20% more on the budget just for that
wow.
fabricator, right? Because they know the next person's going to have to pay for that.
Right.
And but then when it works right, you can have offsite construction. You can be doing things in parallel. You can drop them on the site in big units. They all fit together, and you can really idealize that. And there's so many examples of that over the last 15 years.
Yeah, I bet.
So that's, I mean, if you had to talk about an area that Rhino's used, that's really, I mean, it's used in a lot of other places, but from an architectural point of view, I think that's what that's where it's really honed out. And a lot of, most of the newest stadiums done in the last probably 15 years, those are all, there's a heavy dose of Rhino in those.
Right.
For instance, as an example, if anybody wants to look locally in their area.
Yeah, right. So, Did that shift happen with did you see that coming? Were you really working with that audience to develop the tools to do that? Or was it really the fabrication connection aspect that drove people naturally to your platform because you were already there? It
was both. So the fabrication piece has been there from the very beginning, and the ability to have an SDK and to develop on top of it. So early on, and so a lot of it is just the sheer talent of the people that use Rhino, the customers, and so they would, we had something called Rhino Script, right, which was VB Script with some tools to make it easier to work in Rhino, and they'd write these wonderful, amazing scripts that put these shapes together and got them the information they wanted to, however they wanted to, had to decide how to fabricate it. And that drove us to try to make that work better, right? Because they were doing the work, but it was maybe just too hard, or they want to do something extra. And so this isn't, we don't drive the bus here. I mean, this is always, those two things are always together. And so really these really, really amazing, talented people started putting this stuff together, doing really cool shapes, which are really fun to see. And then, we just tried to march down there, and then all of a sudden, right, you're seeing more and more of this happen. And then you, of course, feel like you want to do it more. And it's even before, that was before Grasshopper, and that was, when Rhino was, maybe Rhino 3, maybe Rhino 2, you're starting to see some of that. And then, kind of, so the rest of this is actually maybe a response to that. So look what they're doing. How can we make that better? Hey, let's try this. And then they'd say, hey, that's pretty cool. And then they'd use that. And then they'd try to expand it, right? Or they'd write their own stuff to make it bigger. And then, so it's always this balance with us. We don't plan. We don't necessarily innovate. We really just try to help people, customers, do what they're trying to do, try to do it better. And the nice part is, they're pushing the envelope of what you're using, right? They're putting all their talent and effort into it, which, inspires us to kind of keep pushing. And then when we do something new, it's kind of cool because a lot of times they're really excited because they can do something they weren't able to do before. And then, what I'm saying, it's this, It's actually this kind of cool dynamic, and it's not, I don't know what we're going to do for Rhino 10 or 12 or 11 or whatever. But I do know, what people are complaining about on the forum, yesterday and today and, the last 5 years. And, and we are always doing that. So it's never a simple answer.
Yeah.
So.
What was that initial release like? Like, what kind of tools were in there with Rhino 1.0?
I wish I remembered. It was, imagine, the some of the curve commands and, your classic one loft, 2 rail sweep, trim, split, join.
Yeah.
Right? None of the drafting stuff, none of the rendering stuff.
So it was really focused on surface modeling at the very beginning, and not like two-dimensional representations of anything.
Not at all. Okay. Not at all. The only reason you'd have the curve commands were in order to create, layouts for the create the surfaces.
So then was it really seen as a companion to a CAD package at that point?
Always is. Rhino always is. That's actually that was always true. It was never, it was never and has really never been a mainline,
like a
how you can classify. Yeah, I mean, Revit's a architectural platform. SolidWorks is Rhino's a companion to all these. I mean, we price it that way too. People always call it a Swiss Army knife.
Right.
It can do those things that other products usually can't. But it doesn't do a lot of things that a lot of other products do. So
yeah, you really hold to solving those problems and not going outside of your expertise and half-assing something, right?
No, we unfortunately think that we probably half-ass everything, but
you heard it here.
Unfortunately, but how do I say this? We definitely are interested in really trying to make tools that work, and it's not like we expect people to be using Rhino by itself. It's part of a process. I mean, it's one of the reasons we read and write 41 different file formats, both NURBs and meshes and sub-Ds, and that's another thing about Rhino that's interesting is there's not many products that are trying to make meshes, sub-Ds, and NURBs all first-class citizens within the same environment, right? So you can kind of translate between them, and you can move between those depending on what you need to do. And, meshes are still bad for fabrication, and NURBs really don't animate very well, and animation tools, you know what I'm saying? I mean, depending on where it's going to go, who knows what's coming in and out. And so being able to make those work together is really great. The only reason we're able to do that actually is because, it's our geometry kernel. And so we do all the writing for it, so we can try to figure out how these very different geometries relate to each other. But it's all the Swiss Army knife part.
I like the analogy of the Swiss Army knife. I'm thinking about your customers and like how wide their needs are, right? And you're not serving one industry, you're serving a bunch of industries.
Right.
And so you can't just go all in on what one customer base really needs when you have that many industries that you're serving.
And we rely on plugins for that. We rely on plugin vendors and their expertise.
So when you were writing this to be very open, like you said, you had an SDK, you have Rhino script. I mean, was that that was how you were going to do it from the beginning, or was that a decision that was hard to make? Like, how did that work its way into the product development?
It was a strategy that we had from the very beginning, in that we didn't think we could write it all ourselves, and we definitely didn't have the expertise to do it. Like we don't understand jewelry, we didn't understand the marine industry, whatever it might be. And so writing that from the very beginning was great. Now, the advantage to that is that you get really talented customers that can write their own commands, and so they're making the product better for you. I mean, they're making the product customized to their workflow.
Right.
And that's really cool to see, and we didn't have to do it. And so that early on kind of encourages people to write that way. Now, we sometimes have to be, disciplined enough to write everything in a way that always has an SDK that isn't just a command, and that sometimes we're not very disciplined in that. But that's something that we did early on, and it's only become actually more and more important. And Grasshopper is actually one of the biggest outcroppings of that concept, although in and of itself, Grasshopper is now a platform.
Right.
Which has exploded on us, and it caught us off guard yet again on what was happening.
When did Grasshopper come onto the scene as a plugin?
I want to say that early on, it was probably 2006, something like that. But it took a long time to move forward. It took a long time to mature through what it is today.
And is that because it was a one-man show? I mean, David
No, no.
put that together, and then it like took on a life over that time, right? But like,
It's because it took a life on itself.
yeah,
It takes a while to figure out. This is an interesting part about the way we do work is it takes a while for technologies and products to decide what they are. Initially Grasshopper was supposed to be, you put 5 commands together and and that's a script, a really short script.
Mm-hmm.
And then and then people were like, well, it could do this and this. And then, all of a sudden what's supposed to be 5 is like 50, right? And it looks like spaghetti.
Mm-hmm.
But it's doing what they want to do. Or this is a good one. So, it's a 5-floor building and they have this copy, this copy, this copy, because we don't have trees, right? So, bang, 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 bang. We don't have lists of lists. And so they need them. So they, do that. And then, we decide, we better put trees in there so that we can have lists of lists and we can have less, everything can be compacted. And then over time, it's like, wow, this is actually a development platform. It's not just a scripting engine for Rhino. And it's not scripting anymore. They're actually doing some really serious work on it. And then, of course, we have thousands of plugins. Some of them just adding components that we never got around to. Some of them, adding 20 components that all introduce a whole completely different way of working in Grasshopper,
Yep.
And so that is out of hand too. It's really cool, but it's out of hand.
But it took on a life of its own. And,
Yeah.
Again, driven by the community, though, right? I mean, this was
Absolutely.
Yeah.
By the talent of the community, it's not just people getting back to us and saying, I need this and this. It's
But
people doing the work and saying, this is, I've gotten this far and initially we used to say, you shouldn't be doing that. Grasshopper's not supposed to be able to do that. And they're like, but it is, it's right here. And so, but that's become a gigantic piece. And it started in architecture. Grasshopper really started in architecture. And what's interesting, you were talking about how we didn't start in architecture. What's interesting is now Grasshopper is being used in industrial design and marine design. Mm-hmm. As it matures, it's essentially coming back around to the original people that used Rhino.
Wow.
Yeah. So it's very, very
That's
interesting.
Cool. Wow.
But you cannot underestimate the impact Grasshopper's had on just as much as Rhino in itself as on all these workflows.
So tell me how it became part of Rhino. Like obviously this was happening alongside Rhino, like through the developer community that David's the best one to explain what happened, but the idea was that we had Rhino script, and so you could script, make simple scripts and it could do things in Rhino, but it was typing, it was hard to type, and so the question was, could we make it more accessible? Could we make Grasshopper, make a scripting language that just was easier? And David came up, it's all David, came up with this idea of kind of this neural network, this network of batteries, components that are wired together, and kind of started experimenting with it. It, of course, worked. And so it was really building on that momentum of that Rhino script thing that we felt. When we knew we had something right, it used to be when we had Rhino script classes and we'd have 30 architects in there, we'd get done with the 3 days and let's say 5 of them really got it. And the other 25 really had to, had a lot more work to do to kind of get their head around it better. And once we started teaching Grasshopper, which is no spelling, good for architects.
Because architects can't spell. Never have been able to.
We all have to look at the keyboard while we type.
That's right, exactly. I'm an architect, so I get to say that, right? So, there would be only 5 people in the thing that really didn't quite get on top of it, right? And there'd be 25 people or 20 people or however many people in a class, but quite a few of the people they get it and they could do stuff with it.
So it was the opposite.
It was just the opposite, just more accessible.
You think that's because of the visual nature of architects in general?
Partially it's the visual nature of it. Partially it is I think like every step, it's always running, right? So every step of the way, when you make a mistake, you got to kind of solve that little mistake.
You get feedback, right?
That's right. That's right. And you kind of keep pushing along. You got your little 3D panel. You keep pushing along, make sure what the outputs are and things like that. And so part of it is that. Part of it is visual. And it just makes sense to people. Where code, is just it's not as easy to read. If you haven't read it for a long time, it's hard to re-engage. Where a Grasshopper script, I mean, sure, if it's gone for a long time, it takes a while to figure out what you did.
Depends how big it is, right?
Yeah, it depends how big it is. But at least it's easy to kind of follow what's going on, right? As opposed to code, where it says, okay, go to the subroutine. Well, where is that subroutine, right? And you find it in some other file that's associated with this file or whatever else. And so part of it's being visual. Part of it is you see all the inputs and the outputs you can use, right? You drop it. You already know what you have to answer to put it in, and you already know what it's, so expectations
of each component, right?
Of each component are really clear. If and it does really hard. It works Grasshopper works very, very hard to translate the data. So you put a point in there, and it needs that's probably not a very good example. You put a point in there, but it needs a plane. It'll try its best to convert that point to a plane, which code-driven programming languages usually don't do that. They usually Python does that a little bit now, but of course that's a little older or a little newer application. Or there are some that are trying to do that, but Grasshopper works very, very hard you can be really sloppy with your data types, and we'll do our best to convert them. So that's part of it. There's a lot of things about Grasshopper that are really I call it magic, but there's a lot of really nice things about Grasshopper that these are all David that make.
And did
Grasshopper
you guys see
really accessible.
See that value right away when that was?
I don't think anybody did. I mean, it's fun to work with. We saw that value. Yeah. Sometimes that's what drives us. It was fun.
Absolutely.
It looked cool. Those kinds of things. But until we got it to customers. Right. And
so
this was
kind of scratching your head, like, what? Who would use this? Like, why?
We always do that. I mean, that's how we. That's
you
how
said
we.
You're slow.
We're slow, but no. I mean, this is always kind of like take a shot in the dark and see what happens, and then follow the customer. And I hate to keep harping on that, but it really is that simple. And try to be open and so, I mean. Every single person in this company, every day, better talk to a customer. And if they're not, there's probably something wrong with our internal processes, to make, because we really got to be close to what people are trying to do, because we're not smart enough to figure it out. So
you've created a lot of job titles. I mean, one of the most important ones that this platform created was computational designer. Right?
Yeah. Yeah.
And I'm sure you didn't see that coming, but now you have these customers that you can talk to who are passionate about solving these geometry problems through visual programming, which was, I don't even know if that was a thing before, coined as a term.
Right.
So, I mean, talk about that it seems like it would have blown your mind, like just to see, like looking back and seeing like how that happened through that software development process.
Yeah, you could say that. I mean, there is no way you could imagine we are where we are. And yeah, there's a whole world of computational design that didn't exist before Grasshopper, let's say. But it was even after Grasshopper. It took a while for it to form up and create these ideas of what they are. And that kind of the size of this, the scale of this really did blow everybody's mind, including David's, by the way. We kind of started to figure out that, wow, this is a platform. This is not just a little scripting thing. And so then you have a different level of responsibility. Like, how do you move this thing forward without breaking everything? How do you, how do you keep it available and running when they change operating systems, right? Because people now have these big workflows and these giant projects hanging on your product, and then we have to get more serious about releasing stuff that works, or making sure that we don't do something to ruin their day. But nobody could have predicted this. Really. Somebody might have tried to predict it. I mean, there were a number of products before Grasshopper that were, kind of pointing in that direction.
Yeah.
Nothing's made completely
like parametric design direction. Is that what you're talking about?
Well, there's lots of different kinds of parametrics. There's mechanical parametrics. There's parametrics that are, there's some where you have 2 points, and then you have a line between those 2 points, and then you'd loft between those 2 lines, and you create you move the 2 points, and then the line updates and the surface updates. Kind of this free form kind of idea. There's tools that use I call them a hypergraph, but hypergraph to edit sound. It's a classic one early on. There's a lot of different parametric ways. I mean, there's a lot of parametrics in Rhino. There's marine parametrics for hulls. There's jewelry parametrics that do rings. Mm-hmm. There's parametrics that do architecture, right? Visual Arc, for instance. There's parametrics that do bridges in using Grasshopper, for instance. That's a really classic one lately. And so which kind of parametrics do we talking about? I think that's an important discussion is, there's different parametric engines, and unfortunately, almost per customer, some parametric engines work really well for this set of customers and some other ones don't. And so, there's solids parametrics, ones that work on straight lines and arcs, for instance. And as long as everything you do is a straight line and arc, that's great. But when it gets more complex, how can you control that thing parametrically? Grasshopper allows us to parametrically control a lot of different shapes. And so I think that is the understanding of a lot of different parametric engines, and that's something we wrestle with. People wanted this parametric in Rhino and that parametric in Rhino, and most of the time you see that with plugins, right? So depending on the kinds of parametrics you want to use, then you can use those things, or you can plug those things in, or you can integrate them into those products. You want architectural parametrics, use Revit, right? But use Rhino inside Revit if you want the freeform stuff, right? You want Grasshopper running in Revit, that's cool. You want to do bridge parametrics, have it go into Trimble Quadri, right? Which is a kind of a BIM bridge linear parametric system, which you have a Rhino inside for that. And that's one of the things I think that's fascinating here is that now can we actually start to integrate these different modeling types and together, right? Because now we have modern languages that we can actually integrate applications inside each other, and try to get them all to work together. And that's been really fascinating the last few years. Been super successful. How would you like to have Grasshopper inside Tekla? And so, but you've got to write all these components, smart Tekla components, right? So that they can fire into there all they want. And that's been another fascinating experiment, let's call it.
Before we talk about interoperability, because I think it falls kind of in that category, I want to go back and just talk about some, and I think this has to do with RhinoScript, but correct me if I'm wrong. But let's talk about paneling tools, because that was, to me, like that was the first real. So there was another application that I was using on the Mac at the time. I think it was called Gem. Do you remember Gem?
I remember the name.
Yeah, it was parametrically driven 3-dimensional geometry, and you could do pattern-based stuff. And I think
it was good at patterning. Yeah.
And then when I saw paneling tools, I mean, that to me really, like, it spoke the same language to me as an architect, thinking, oh, I understand what that means. I mean, talk about that, because it's still there, right? I mean, I think that's what's so interesting about Rhino too, is like it never forgets anything. You still have all this stuff from all the years, and people have moved on to other things, but these other things are still there, right? And they live inside there.
Yeah. So paneling tools was really a response to people trying to do facades, obviously. In architecture, and having these really big surfaces, of course, but ultimately in the architectural world, everything pretty much has to be cooked down to some sort of straight line, right? Because that's how our stock comes. And so Raja was the one that did that. And how do you get a structure, a grid structure that you can use? But as we started to, and this is interesting, you initially idealize a strategy like this. How do ideally this surface has the right UV, it's structured a certain way, so you just have to break it down UV wise, and then magically, it just happens to fit the thing.
Just populate it. Yeah, that's cool.
It just populate it. As long as the surface was built correctly, that's always the key. Then the rest will just take care of itself. And this is actually a good example of how we develop things. So, of course, that's the first place you're going to go. You got this ideal surface, you're going to hit it, you're going to get this grid, and you do whatever you want with it. And then, of course, not 2 days later after you let it out, somebody comes back and says, well, I got the shape that looks like this.
What about this edge condition, Scott?
Right, and the UVs are going this way, and the other ones are going that way, and it's all this, and I want this, I want these things to come down here, And you have two choices, right? You either say, well, okay, obviously UV is not going to work, or I could force the customer to say, hey, you've got to create a better surface, which is essentially telling them they got to change the shape.
Yeah.
Right? We can't do that shape, right? But no, what we do is, okay, how do we do this one? Well, okay, on this one, even vertically, we're just going to slice it vertically, and then horizontally, we've got to break it up by points or something, whatever it is. And then, so we have these 10 or 12 different ways where you can combine how we're slicing it this way and how we're doing it that way. And then we got to figure out how to, how you can walk yourself across that so you can make a grid and have index points. And that's actually a really good example where just based on customers trying to do stuff, the thing gets more and more robust. Sometimes, unfortunately, also more complex, but more and more robust to do these crazy stuff, just this crazy, crazy things. And what's great is now when somebody gets a hold of us and says, how do I do this? You can say, hey, here's the tool, here's paneling tools. And then you get to see all the things that are resulted from that. And that actually drives us. That's actually, it goes back to the same thing. We just love to see what people do with this thing.
Hey everyone, let's take a quick break from the conversation to pay some bills around here. This episode of Troxel is brought to you by Troxel Plus members. That's right, my incredible paid supporter members are making this episode possible. Their direct support ensures that I can continue exploring the intersection of architecture, technology, and the future of design with the leading voices in our industry directly to you. So let's talk about why you might consider financially supporting the podcast too. By becoming a Troxel Plus supporter, you're not just helping sustain these conversations, you're also gaining exclusive benefits like ad-free episodes of the show and my Leadership Edge email newsletter, where I analyze episodes and deliver the insights and key takeaways right into your inbox. Your small contribution makes a huge impact. And if you've been enjoying Troxel and want to be part of the community that keeps it thriving, please consider joining today. Head on over to trxl.co and click the subscribe button either in the upper right-hand corner or at the bottom of the page, or you can visit the link that I've put into the show notes. Once again, my sincerest thanks to the Troxel Plus members who have made this episode of the podcast possible, even though they aren't even hearing this ad because theirs are ad-free. Now, let's get back to the conversation. I had a lovely conversation with Raja at AU one year, just sitting at a table, breakfast.
Yeah.
Oh, hey, what? I didn't know who she was when I sat down next to her, and by the end of it, I knew exactly who she was.
Yeah.
It was a moment, and I'm like, oh, you're Raja.
Yes.
I
Yeah.
know who you are.
Yeah. Raja Isa. Yes. Yeah. She's
Raja,
amazing.
she is amazing.
Yeah.
So shout out to Raja for sure.
Yeah. Definitely.
So let's talk Rhino 5. You introduced Rhino for the Mac at that point, I think. Was that when it first started, or was it 4?
No, it was 5.
Okay.
It was 5.
And it was different. I mean, it was different. It wasn't
very
Windows
different.
Rhino. It was Mac Rhino, and it was
Yeah. And
what drove you guys to do that? Was it customers asking for that, or was it you felt like you needed to be there?
I think that I mean that's a really difficult one to figure out what drove us there. I think part of it was, students. We have a very, very strong student program. Our product, students can buy it at a very inexpensive price, and they can use it commercially, right? They can use it after they graduate and all that stuff. And there were a lot of students that had Macs, so they couldn't they couldn't access Rhino, even though they wanted to. And so we kind of wanted to see if they'd use Rhino for Mac, even if it was a version that wasn't at all as mature as the Windows version, because the 5 version was different in a lot of different ways.
Yeah,
and there are a lot of things.
It didn't have all the features. The interface was different.
Right.
Did it even have Grasshopper in the beginning?
Nope.
No. Okay.
Nope. And it's a real debate when you do cross-platform. How do you do that? Like, do you make it like Windows on the Mac, or do you make them both native like they would be, right? Like you make the Mac version like the Mac version, the Windows version like the Windows version, and so in Rhino 5 it was different. Rhino 6 was different, but it was better. Rhino 7, we got to the point where it wasn't exactly the same, but we could at least release the code base at the same day. So it was kind of getting to the same code base. Rhino 8, there's even more that's working. Grasshopper does work. Some Grasshopper plugins work. Not all Grasshopper plugins work. But there's a lot of almost everything that you can do on the Windows version, you can do on the Mac version. Now what's interesting though is in the 8, we're actually seeing the Mac version affect the Windows version. So we're seeing some cross-platformness.
Some influence
from the other
direction.
The other direction. And the way we write that now is we actually use the same code base for both. And the way you have to do that is we use an interface toolkit called Etto, who Curtis, who works for us, develops that. It's open source, but he's the one that develops that. And so you actually write to Etto, and Etto is the one that kind of manages how it shows in Windows and how you show it in Mac. And it's not that everything, I mean, it's, say it's 90% the same now. It really helped a lot when Mac came out with some much stronger silicone. Mm-hmm. So that's helped a lot in the last few versions. I mean, the video performance has been so much better.
Oh yeah, the real-time rendering is
that was
a big deal. All of a sudden you turn that on, it's like, whoa, this is way better.
Yeah, exactly. And so that's helped a lot with the Macs. I would say probably half our developers now are just actually develop on the Mac, because you can actually develop for both platforms now, one spot. So that is something that's moved forward a lot. We intend to continue to do that.
One of the things that you guys did that was so good, I mean, just from a laptop standpoint, because so many people everybody's on a laptop, let's just say that, we'll generalize. Mm-hmm. But man, the trackpad support on the Mac version of Rhino has always been just absolutely perfect. It's just like totally natural to be in a 3D environment without a mouse on the trackpad. It's just chef's kiss.
Well, we appreciate that, and thank you. The frustrating part for us is we can't do the same on Windows.
Yeah, I bet because it's
'cause
so good. You don't know what
it's
you're
a
missing if
different,
you haven't tried it.
exactly, and it's just difficult to because they don't have exactly the same messaging, event messaging that the Mac side does have. But yeah, that's an area that we worked hard on, and all of this stuff. I mean, all of it, just going cross-platform has been a journey. It actually makes our code better because you don't cheat. You can't cheat for Windows because it won't work on Mac, and you can't cheat in Mac because it won't work for Windows. Some people call that cheat. Some people call that a hack, whatever you want to call it. But it does keep us a little more honest in terms of that. In Rhino 8, all the development tools, the script editor and all that stuff, they're the same on Mac and Windows now, which is really great. And so, we continue to try to make those two platforms equal. License-wise, if you buy one, you can run it on the Mac or Windows or both.
Yep.
Yeah.
So let's talk a little bit before we move on out of the Apple ecosystem to iOS apps. So you do have iRhino 3D running on iOS, which includes iPhones and iPads, and
that's right.
There's some really cool features if you're on the test flight version of those. If you're not on the test flight version, you should be, and it's free to do so. And but if you wanted to use Apple's, what do they call it? Room kit or room plan or something like that. You can actually scan spaces and it builds native Rhino 3D models out of that, which is super cool with dimensions and you can scan objects using the AR kit, or it's basically using the LiDAR cameras on the phone. And so there's a lot of really cool little features in there that you guys are. I'm sure there's some kind of influence even there with like prototyping some things on Apple's with their Metal APIs and testing these kind of new technologies with scanning and capturing and all these and
it's all been kind of a linear work for us, so Mac came out with, they're going with Metal for their graphics engine and that we had to do that for Rhino for Mac for 8. And then the iOS came, development started, and that's actually the same code that we run for Mac and Windows actually is on iOS. It's just not all of it's turned on. And that's yet a third platform. And so, we tapped into, and this is probably because it's just fun, we tapped into some of those tools that come on iOS that don't exist other places, like the AR, like the scanning. And those change, Apple's come and gone with those technologies a little bit. We had an older version of iRhino that we wrote, and it was really just a viewer. And that, of course, has been obliterated, and we have this new one, which, like you're saying, the test flight version is the place to be, because that's where we're adding new things. And Morteza, who does that, we're always adding, new features and trying to figure out, how do we navigate, how do we, look through layers, how do we deal with views,
You can even build a few shapes in there now, I think, right? Like
yes, you can. Right.
You can model on your iPhone.
So a little bit,
a little bit.
Yeah, a little bit. I mean, that scanning technology is by far the best way to use it in terms of generating models, because it's so fast. But you can do a little bit of modeling, and so we're trying to figure out, again, trying to just follow what people are doing with it, what they're trying, and test flight's the place where that happens, and really kind of working through, what people are going to use this for, and how it complements their workflows. You can mark up things, you can, you can kind of do your markups, and that saves with the 3DM file and all of those things. And so we continue to kind of work through what that's going to mean.
Very cool.
So.
Well, let's talk interoperability, and let's talk about your Trojan horse strategy that you pulled out on everybody. I think we talked about this a little bit on the podcast before, but let's since we're telling the Rhino story here, where did Revit fit into this? How did all that happen with Rhino Inside?
So Rhino Inside was our, the ability to pull Rhino apart so we could load it other places. And, the iOS, you could actually call that part of that too. But so we could load it inside other applications. And the ideal was originally just like you could make your own application and you could pull Rhino. You could use the Rhino functionality in there. And somebody just thought, well, I wonder what it would run in Revit, and just for fun. And then they tried it, and of course it worked. That was Kike. And one of the big, we talked about architects using Rhino. One of the big requests we always get is, or used to get more, but no, is how do I get my Rhino information into Revit, right? I want to use, we're going to use these two products together. We talked about Rhino always being a companion to other processes. And so how do we get that information back and forth? And you can try to use file formats. The problem with file formats is you're going to lose something. It's going to format information in a certain way, and it's going to put it in the other application in a different way, and maybe in a different way you want. And so one of the things about Rhino inside Revit, which was, we can now use Grasshopper to take the geometry and the information of Rhino and rearrange it in a way that's Revit friendly. And so you can, take these and you can categorize them the way you want, and you can create native Revit objects if you want, and however you want to do that. And then you push all that stuff in there with all the right parameters. Or you can grab all the parameters from over here and throw them into Rhino so you can remember what it all means. So anyway, push it back and forth. And so it bypassed these pre-cut file formats. I mean, that people, a lot of times they use Excel, right? So they take Grasshopper, or they take Python or something, and they write all these points to an Excel spreadsheet, and then they take, Dynamo or Python or something in Revit, and they'd read all that stuff and so as long as you could translate
great translator of
that's
Excel.
Right. As long as, and everything translated to a point, right?
Yep.
Point in a cell. Anyway, we could bypass all that by saying, okay, we know the Rhino information because we're sitting in Rhino. Grasshoppers can, be to wire everything together, push it into Revit, or take stuff out of Revit and use that as a reference and throw it back in. And that has been huge in terms of bypassing the weaknesses of file formats.
I think the podcast we did before, the title of it was "File Formats Are Terrible," if I remember that correctly,
or dead, or something. Yes.
But it was this idea that you're talking about. It's like skip the files completely, and just let them talk to each other. What year did that project start?
Oh, I want to say that was probably COVID. So maybe right before COVID.
I think it was before, because
it was just before COVID.
Right.
Yeah. COVID kind of
and it's grown as well, right? It started with a certain number of functions that you could do inside, that talk about like that.
Yeah.
Is that again user driven?
Oh yeah. I mean, before it was, let's make some direct shapes, right? Or we must be done. It's like, no, we'd really like you to make columns and walls.
I remember when you guys published your documents, right, on how to use it. And I'm like, oh man, this website is going to need to be updated every single day.
That's correct. That's correct. And I mean, it's getting longer and longer and bigger and bigger. And it's like, oh my. I mean, we actually had to invent what we call pass-through components, right? Because in Grasshopper before, you'd have components that input and it would make something, and you'd have a different component that would take something and then output it. Like simple version, right, is I've got 3 coordinates, make a point, and then I have this other component that takes a point and it'll make 3 things. Well, we decided if we had to do that, we'd have twice as many components. So now we all in Revit, and this is actually true in Grasshopper in general, but now we have them where you've got you've got the point going in plus the 3 coordinates, and you've got the point going out plus the 3 coordinates. And if you feed a point in, you'll get the 3 coordinates out. And if you feed into the 3 coordinates, you get the 1 point out, but it's one component that will do both at the same time. And
nice.
You can do interesting things like bring the point in and only feed the Y, and it will just change the Y value of that point going through, kind of thing.
Nice.
But that, we had to figure out how are we going to do this with all these Revit components now that we have to add to Grasshopper as a plugin, right? You can install it's free, but not everybody gets to see them. But if you have Revit floating around, you can throw it in there. But now also, we have Rhino inside Tekla, which has been really popular. Rhino inside Quadri. There's experiments with Rhino inside Blender, Rhino inside SketchUp, Rhino. There's a lot of different ones. The main three are the Revit, the Tekla, and the Quadri one. And those have been really popular. Rhino inside Sophistic is another one. So there's a lot of different inside projects that are happening.
Are those all driven by McNeil and Associates, or are they happening through outside developers who can really put their knowledge and passion into those projects?
Yeah, a good example is the Rhino inside Tekla one's done by a Tekla developer, done by Trimble, or they're actually doing it. And part of the reason for that is you really have to understand, to do this, you have to have intimate knowledge of both SDKs. And that's, we happen to have somebody that knew the Revit SDK, but these other ones we don't understand their SDKs. So it's really helpful that they're doing it. In fact, it's the only way it works. Although we work with them really hard if there's something that's confusing or doesn't work very well. Of course, we try to solve it. But I think that inside technology, it continues to be an interesting frontier. And it's not. Still don't see it a lot around. I don't see other products doing that yet.
Yeah.
So. Yeah.
Well, you talked about how Revit kind of influenced the development of certain components in Grasshopper. What other modeling tools have influenced what you guys have done, maybe more recently? Can you think of any examples? I'm thinking of something particular, so I'm kind of testing you.
All right, I'll let you tell me what you're thinking about.
Well,
I don't
push
into a
pull,
hole on.
right?
Oh yeah, so push pull is a good example, right? So push pull is a sure it was an interface kind of explored through SketchUp, right? And proven to be useful. So
yeah, very proven, right?
Right. Super proven.
When you talk about sculpting,
Gumball is the same thing, right? So
yes.
Gumball's been shown. Countless applications have gumballs, and for us, we're just a little slow on the get up for that. So yeah, there's definitely. Part of it is it's not, and we really don't like it when the customer comes to us and say, "Can't you just make it work like XYZ?" Right? That doesn't work for us.
Yeah, and I think you guys proved that with push pull. You made it a very Rhino version of that.
Yeah, different, but the a lot of times customers are like, I do this over here, right? This is, I know this works for the workflow I'm trying to shoot for. How can we do that how can we make it easier in Rhino to do this, that, or the other thing? And so there's some there's always a little bit of crossover in that, that it's not that we're just trying to do it. It's just that customers sometimes say, "Hey, here's workflows that work pretty well," and then we go from there. And we tried to do it in a very Rhino way, so they're always a little different. But
yeah, I think one of the videos I saw that you had published was how to build a table using only the gumball. Right? It was anybody who's experienced in Rhino would never do it like that. But somebody who's coming from somewhere else might be like, "You just unlocked Rhino for me," when they see something like that.
Yeah, and some tables work really well done that way. Other tables don't work very well at all.
True.
But it's true too. We talked about Rhino's meshes and sub-Ds and NURBS, both surfaces and solids. And so how do you get that technology to work with all three of those geometry types, right? And it's hard. It doesn't always work the same. Pushing and pulling on on a sub-D face is different than pushing and pulling, on a NURBS thing.
Yeah.
So a lot of experimentation, a lot of getting it out and rewriting it when it doesn't.
A lot of
work very
failing.
well.
Right.
Yeah, a lot of failing along the way. Yeah. Well, we always like to say, if you haven't rewritten it 3 times, there's still another rewrite coming up. Don't know when it's going to get to you, but it's going to get there. So
it's interesting how you're still, like I said, Rhino never forgets anything, right? It's like you're very like you have all these tools, you've just continued to build and build and build and build, and you maybe ever had to rewrite things, and some things get just kind of shoved off into the corner because not very many people use them still, but they're still there. I'm just thinking about like the overall UI and just the way you use Rhino, a user, the way they use it. I'm sure lots of people customize it and make it look how they want, but like the underlying, like if you just defaults, open this thing up, you've got the command line, you've got a graphical UI, you've got a command line UI, and you've got these shortcuts, right? The commands themselves, right? And the keyboard driven, like that goes all the way back to the beginning, right? And you can never take that away because your user base will scream, right? Like
That's correct.
You can't shift the paradigm of Rhino and release it as Rhino. You would have to come out with an entirely new product to do that. But kind of talk about, like, from this to me seems very McNeil. Like, you've talked about, you're this private company, you're small on purpose, you've always thought of yourself as a companion app, you've kept all this stuff in Rhino all these years. The way that people use it hasn't really changed. That just seems to be the ethos of McNeil and Associates in the Rhinoceros 3D application.
Well, yeah, and it's both a good thing and a bad thing, right? So, we have so many customers now that when we start to change things, right? You got people that say, I've been doing this for 15 years like this. Why did you change that? Hopefully the way we changed it allows us to build more, right? So one of the challenges that we have now is a lot of times, in order to move an area of the product forward, you have to be able to rewrite it. You have to write it in a more modern way. You have to write it, because now, you realize what it is, but it needs to, it needs to be more. And that's a real challenge, is how do you grab parts of it and rewrite it so that you can move it forward in that new direction. The technology is not old. It's not, it hasn't been kind of stretched and hacked enough. And I have to say that I've been really proud of our team in that they've been willing to take that risk in a few areas. And not that it's always gone perfectly, but we are in a process of, we will rip out a piece and we'll put something new in, and try to make that work. Sometimes that is a necessity. Sometimes it's by our choice. We'll go through that pain. But how do we keep that? How do we keep this product fresh and the platform? How do you keep the platform fresh after 30 years? Right? How do you keep, this moving forward, and without, because there's a lot of products that have essentially atrophied, and it's very easy to do. There's a lot of terms for that, but it's something that it is risky. I mean, writing software is a risky proposition. We're writing software hoping somebody will upgrade to it later, and trying to rewrite something to make it better means you're going to make it different. And in making it different, not everybody's always super excited about that.
They're not along for the ride necessarily, right?
Well, and
they vote with their dollars, right? I mean,
yeah,
you have
exactly.
Yeah.
And so, but it is. I have to say that you're hitting right on something as these products get older. It's a real challenge to how do we continue to keep it fresh, but respect all our existing customer base, right? Because they want it to improve too. I mean, everybody wants this to get better, right? It's just that sometimes that's a little hard to do with the existing technology base. So So we've done a good job. I mean, we're a small company, so we can take those risks a little bit, and it's been really good. But we have some people that are working really hard to try to, replace the right pieces of the product. We didn't think we'd be doing this for 30 years, so we didn't quite plan for this. I mean, come on.
Right.
So,
how could you? Right.
Yeah, exactly. I mean, that's the mind-blowing part, I think, is we're still here.
Staying power.
The staying power, and it's still exciting. I mean, it still feels just like it did 3 years into it, or 1 year into it, or whatever, and so that's really cool. So
that would have been a great last line, but I'm not going to let you off the hook yet.
Oh.
Well, tell me about pricing and perpetual licensing and like your company's stance on all that, because this is another part of the story that I think, I mean, you have customers who are so loyal and are so rooting for you. And I think this is a part of that story. It's not all about the money. It's a lot of the whole recipe that you guys have haphazardly thrown together here, right?
Yeah.
Like it's just happened the way that it's really organic, and but you definitely have some really strongly held beliefs that underlie the way you do business.
Yeah, so I mean, a big part of we charge less for the product than a lot of other products cost. And there's a lot of reasons for that. One of the reasons is that we think of ourselves as a companion product, right? So there might be a lot of money on the table, but we don't want all that money because you can't buy other products and you'd have to figure out how to use only Rhino by itself. But we're a private company, so we can run things a little bit differently. So for instance, we don't do a lot of marketing, and we hope that people realize that we pass that on to the customer, so so we can keep that price down. Students, a lot of innovation in workflows with students. In fact, I would say most innovation in 3D workflows come from students ultimately, right? Because they're the ones that actually have time to experiment. Get them give them a break on the price so that they can get to it.
They're not coming in with all those preconceived, this is the way I've always done it. They're figuring it out.
Yeah, right? and they're not sitting there on an hourly per hour basis trying to get a project done. They can experiment. They can, they're talented. They have fresh ideas, and they do
different influences.
Very different influences. And so, that's an area that is part of the thing. Now in terms of perpetual license versus subscription, I guess you'd have to call it. I mean, that's what most people call it. Is I think that is really just us being defiant, right? That I mean, it has everything to do with because we can, because we don't have to go to subscription, because we can. It doesn't mean we never will. It doesn't mean, if customers, there are actually certain customers that want us to go to subscription because, for instance, they can, pay us the same amount all the time. But generally, we find that the majority of our customers, they don't want us to go to subscription, so we don't, and there is a freedom to that. There's a lot of reasons companies go to subscriptions. We don't have those reasons. So I mean, pretty much because we can.
But to your point earlier, you have to then develop before collecting, right? You have to do all of that work in hope of upgrades.
Yes.
Yeah.
The software game is a game of gambling, right? You do all the work, and then you try to collect the money, and you hope that the work you've done now, will people will appreciate it, and they the thank you note is paying us for the work we've done. So it's constantly a gamble. A lot of people don't think about it that way, but in fact you're always working for the next thing. it's part of the reason that we have such an open beta program. You know, we
Yeah, I wanted
publish
to
like today you can get Rhino 9, right? If you own Rhino 8, you can download Rhino 9. Not that there's much in Rhino 9 beyond what's in Rhino 8, but there are a few things. You know, and we release that every week. And it's essentially we release it every week because we want customers saying, "Yeah, you're still on the right path. You're still on the right path."
Well, there's accountability there. I mean, you're showing your work. I mean,
Yes.
you are literally developing in the open, in the public, when you run it this way. I'm really curious about this whole thing.
Yeah. And you have to allow yourself to do that. So you can't plan very far. You can't, you've got to have developers that are willing to talk to customers. I mean, there's 1,000 different ways you have to set up the company so that you can get this interaction. You know, it's not like we have 4 months of plans and, oh, thanks for the request, but you have to wait 4 months, right? Because I've got this long list of stuff I have to do.
Yeah.
Now, of course, sometimes they might say, yeah, that's going to take, a year. That's not, no question. That's
work sessions on the Mac. Come on. It's been a cut.
Exactly. Great example. Right. I mean, there's 1,000 things thousands and thousands of things that we can't get to, but that is a good example where we're kind of trying to keep ourselves understanding what is really of value. What is really the valuable piece here? I mean, we can make up stories internally, and we do quickly, because most of the time those are out the window in a week because you're kind of marching along little tiny pieces. So we almost always now, in fact, probably 2 months after we came out with 8, we came out with a 9 beta that you can download.
You need to call it the right thing. You got to call it the whip, right? This is a whip.
Yeah, it's currently the whip. Okay. So, and it's a good example. I mean, we should go over that term because it might be useful. But work in progress is when we're adding new technology, and who knows how well or poor it's going to work. And then at some point, we'll go, and this will be quite a while, right? Because we only come out with stuff every 3 years or some new versions, a couple of years, 2-3 years, something like that. When all the new technology's in there, but we need to fix bugs, refine UI, integrate it with other things that maybe it affected. That's when we go to
UI. Yeah.
It might be creating a UI because currently there's a command line for it or something. Then we'll go to what we call beta, right? And hopefully beta is that process of refining it a little bit, fixing the bugs, documenting it.
But you're not trying to add anything new at that point. Like, it's locked of the feature set for the most part.
We'd like to kid ourselves.
Let's just say that. Yeah.
Let's just say ideally
what's the story that you want out there, right?
That's right. That's the story we want out there. As long as we didn't forget some really fundamental,
obvious, right?
Something obvious that we missed. But then, so we have the work in progress for 9, out there, and then we're working along with that, and so people have both 8 and 9 on their computer, and they do their work with 8, and if they need something 9, they play a 9, or it might jump in and use one function and then bring it back. That works. But
you
that's
don't recommend it for production work for obvious
especially
reasons.
Right now, right? Because it's
early. Yeah.
Once you get to beta, you're a little safer. But that's I mean, how we have to work. I mean, that Rhino 9 is the way currently you work with our devs. I mean, it's not, and this is actually internally, always a balance. Like, when do we fix things in 8 because they're a bug? We have to fix those first, and then you take the time to add something to 9, right?
Because you're trying to get people comfortable with production in 8, right? As professionals.
Well, yeah. No, I mean, you're still working on that, but you still have to be pushing 9 out a little bit, and there's certain things you're like, I don't know how well this is going to work, so you got to throw that in 9 so it can get beat on, so that the people that are trying to get production work done in 8 don't get interrupted.
So an example of this was like in 7, right? 7 was the model that was the real version, and then you had the 8 whip, which was really pushing sub Ds, I think. Is that the right?
That was 6 to 7.
6 to 7.
6,
okay.
7.
So yeah, you would jump over to 7. You'd have them both
Right.
installed. Again, I like
Right.
how you guys have set this up. You've structured it so that you've got to have a bit of skin in the game, right? As a customer to be current with the latest release version number, the big number, 8, 7, whatever it is. But then when you do that, you also have the option to play with the work in progress and, like you said, new technology that's being added in there, right? And so
Yeah.
I'd go over there and in the beginning it was all command line sub D stuff, right? And then you added interface and you added more commands, and people on the forums are like, "Hey, I really need this thing. I've been using this in Maya forever or whatever, and I need to be able to, flip the edges or crease this or whatever, add weights, whatever those things are for sub Ds." And you slowly see those things happen, and then when Ace 8 comes out, it's got a pretty decent first round of sub D tools, right? 7. Sorry,
Yeah.
I keep saying the wrong number, but
No,
like
I
that's
know where
how
you're
it
going.
works, right? And so you can actively participate in the development of that next release while being, doing production work in the main stable version, which
That's
is
right.
one number less.
One number less, and that's critical. That's critical to the way we do and what Rhino is, and participating in that WIP process is, you really can have a lot of influence on where the tool's going. And I'd always highly recommend people at least get that on their computer and play around with it. I just, for fun, I've been playing around just the last couple of days with using Grasshopper as a hatch pattern generator. And so we put a bunch of tools, a bunch of components in Rhino 9 to generate hatch patterns in multiple different ways. You can imagine with Grasshopper, there's a lot of really cool ways to do it. Clean ones, difficult ones, but now you've got all these little components, and you can flip a couple numbers up here, and you generate all these different hatch patterns.
Very cool.
Yeah, it's really, really kind of cool, but it's taking some time to figure out exactly how those work together, and we're doing that in the WIP. Right? Because this component comes out and it kind of works. It sort of works for all the things you'd think about, but then there's, 10 things people try on it that we didn't think about, now, so we're changing that. So you can't count on that component being really consistent for the next 2 years, right? I mean, obviously, let's say 4 months from now, that component probably won't change after that. But that's the kind of thing. Now I'm getting work done on the meantime. Now, of course, I'm getting work done with it in the meantime, but you just can't, base a whole workflow for the next
Fully
5 years.
depend on it.
Yeah, on that. That's what the existing version, which is Rhino 8 currently, is to do. So yeah.
Let's talk about Grasshopper 2 for a minute here. So I mean, what's crazy is you've had Grasshopper in Rhino since 6, I think you said.
Mm-hmm.
And it's version 1, right? Like it's 1 point something, but it's 1.
Yeah.
Like it's still this original idea. And so talk about where you're going with that.
Well, I think before we talk about 2, we do need to talk about 1. So 1 is the same concept that it's always been, but we do continue to add whole new
tons
sets of components. In Rhino 8, we came out with this idea of content cache and being able to track objects in Rhino and being able to manipulate actual Rhino objects within Grasshopper's data types. And that continues to push forward and really revolutionizes the way you can use Grasshopper in Rhino. And so Grasshopper 1 continues to be actively developed and added.
That's by no means a thing that's just coasting.
Right.
Not at all.
right. And we have a crew of people working on that. And then Grasshopper 2 is a reimagination of, now that we understand what Grasshopper is used for, how would you write Grasshopper
if you were going to do it all again?
If you were to do it all again and approach it based on what that is. And so that's available. You can download Grasshopper 2. But David's doing a lot of that work. He really he's allowing himself to really touch everything and rewrite everything and reorganize everything. And that takes some time. And
there's some new frontier there, right? I mean, so much has been learned, and just like you've absorbed how people do things they aspire to do, and this reimagining, the potential there just is enormous.
It is, and development languages. I mean, now that we think about it itself as a development language, and development languages have become more and more sophisticated, higher level. Mm-hmm. And so, for instance, and I know this isn't super new, but the idea of a class and a class template, and how does that now affect Grasshopper, right? How can you make an object, which is a piece of data, but it has other kind of members to it? And then as that flows through the deal, what do you do with that? How does that class morph, and how does it, adopt? And we don't call them classes, but the just this idea of that sophisticated way of dealing with a data structure, how could we integrate that into the system? And that's part of it. There's some really amazing kind of technologies surrounding passing a function down the stream, down the pipe, instead of a piece of data, so it can be dynamic, right? As opposed to just, here's the value of this function, pass the value down. Let's just pass the actual function down the stream. Yeah. And how does that affect all these other pieces? And that's something that David continues to evolve with, and new interface paradigms too. Yep.
Right? Like the way that you interact with it.
The way you interact with it, the way it looks, but the way you interact with it. And that's always been something that I always felt like is really great about, it's just how Grasshopper feels when you use it. There's just, and Grasshopper does the same way, just like, it's just sitting there and actually feeling your way through the technology as you're using it.
Delight.
It's so key.
Yeah.
You get close
to use. You
get close enough to an input, it snaps to the right spot. And you don't see it. I mean, you don't know. I mean, you notice it because it feels right, but not. But that takes. I mean, to work your way through that. I mean, it takes a lot of just
sweating the details.
Yeah, it's the details, and that's something that I think that has always been right with Grasshopper. To David's credit. If I haven't said his name enough today, but
say it again, he might appear.
He is truly amazing, and so kind of working your way through that, and so there's a lot of that going on with Grasshopper too. Like I said, you can get it. We continue to look on trying to figure out how we're going to get all these technologies to attach to it, but it's going to be a while. I mean, Grasshopper 1 is going to continue for a long, long time. In fact, who knows, maybe forever. Grasshopper 2 is in parallel. It's not meant to replace.
In true Rhino fashion, right? You're not going to forget about. Yeah, and there's so many scripts out there that rely on one that are just going to continue to be useful, right? And necessary, that you're going to have to keep Grasshopper 1 around for, let's just say forever. Yeah.
We used to think, initially it thought that we'd have to throw out all the Grasshopper 1 stuff, but David figured out how to run Grasshopper 1 components in Grasshopper 2. And so
we call it Grasshopper Inside. Yeah.
It is. Actually, oddly enough, that's exactly the technology it is. Nice. Did you know that Rhino is Rhino Inside?
No. Rhino is
Yeah. So if you go look in the programming, in the program thing, Rhino.exe is this tiny little thing.
Okay.
And Rhino core.dll is this monstrous thing, which is actually, that's what you load when you do Rhino Inside. So this little Rhino.exe thing actually runs Rhino Inside.
Oh, wow.
So Rhino is itself Rhino Inside.
These feedback loops are incredible. I mean, what
they are. And if you think about them too hard,
I
would highly recommend not doing that. Yes.
Okay, so let's finish up. Let's wrap up. Mm-hmm. I want to just, how have you been blown away by your user base over the years? I'm sure there's a million ways, but like project-wise, what people have been able to do with it, there's got to be a a story or two that you could just what like just comes to you immediately when I ask that? Because
Okay,
man,
so
I've seen some stuff that I'm just like, I bet the McNeil folks are just completely blown away. I'm blown
we
away
are,
by
and
this.
every
But
day,
you guys are the parents of this application.
every day we are surprised, and it is like a child. Is if for those of you that are parents, it is like a child. It's like when they grow up and they start doing stuff, and you are just like, oh my goodness, I can't even imagine that they did that. Right? They're obviously a little bit older, and they've got this and that talent, and so every day we're blown away by stuff. But my two, I mean, one is because I'm an architect, and was Sagrada Familia. So the Sagrada Familia in Barcelona, was destroyed by in the Civil War. All the drawings were destroyed, and a lot of the models that Gaudi had made. And this was actually really early on in the 90s. They started doing this at MIT in Australia. A lot of what he did was mathematically driven. And so they started using Rhino to put these shapes back together to try to figure out what the original design was like. And they ultimately modeled the whole thing in Rhino, and they used that to actually create, what they're doing out there.
Wow.
And we used to talk to the architects that were involved in that, and that's such a beautiful building, and it's and complex and organic and mathematical at the same time, and that project always has blown me away and continues to.
Ticks all the boxes, huh?
All the boxes, and it's Rhino modeled.
That's incredible. Last time I was there was 1990. Well, the only time I was there was 1998. The entire interior was full of scaffolding at that point.
Yeah. Now,
and I've seen pictures of it now, and it's just.
And you go in the afternoon when the sun's low. One side of the windows are warm reds and oranges, and the other sides are blue and greens, and all this light comes into space, and it all mixed together in rainbow colors. Wow. And it's just fascinating. Anyway,
what a cool story.
That's got to be one of my favorite architectural places. Although I there's so many of those in the world that are just great, and I could go on forever for that. And what was another one? The movies. So many blockbusters that have computer graphics in them. Star Trek, Star Wars, Men in Black, Lord of the Rings, blah, 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 all these things. A lot of times they have to create a computer graphic version of the objects, but then they have to make a physical object to interact with the actors. Mm-hmm. And that's the world of Rhino. Is because they can fabricate it for real, but they can do these crazy weird shapes. And it was always so much fun to, walk on the set of Mission Impossible, and you're walking around, and I can talk about this now because, of course, the movies have been come and gone years ago. But, you're kind of walking around. And first of all, you can't imagine you're in the middle of this, and these people are wonderful and smart and creative, we're just trying to, just lucky we're there. And anyway, you're sitting next to a set of stone stairs, and you're looking around, and somebody comes by and just steps down and grabs those stairs and puts them over his shoulder and walks them down the thing. and it's like physically and psychologically, it is surprising to you because those were stone stairs. You were standing right next to them.
You just broke me. Yeah.
Yeah. It's like, it's just your whole body goes, what just happened?
Right.
But to go see all that creativity and see how it comes out in the movies and things like that. And we live vicariously through all these kinds of projects. It keeps us going.
I bet.
Yeah, and it's so much fun.
That's really cool.
Yeah.
Yeah, I think about a particular slide in a presentation from friend of the show, Brian Ringley. He's been on the show a few times.
Oh yeah, Brian.
And he was like,
great.
It was about visual programming, and it was like, here's what people think it is, right? And there's two columns, and it was like making weird shapes, right? That was like number one, right?
Right.
And what it really is was making weird shapes fabricatable, and it, because it's logic, right? I think that's what is so interesting about this approach to creation of physical objects. Like, you can imagine these things. If you can come up with a logical way to construct them, you can take that exact same information and make a physical thing out of it.
And makes it possible.
Yep.
Yeah, absolutely.
And that's just a great way to explain it to people who don't understand it or are coming to this for the first time. And it's like, there is this logic behind all of this. Like you said, like Gaudi's Sagrada Familia, it was math based, right? And so because it was, then you're able to build these forms, so to describe them in 3 dimensions that can then be built, right?
Right. And I always like to say is if what you're designing doesn't draw well in 2D, then use Rhino, because you can get people the information they need to get it to built. I remember good old days, right? You'd have the 24 by 36 sheet, and then you'd have this line going down the page like this, and every 6 inches it's like down 2 inches, over 4.5, down 3 inches, and they're trying to give you all the dots of that section, plot all the points. Now the only thing I can tell you, if you take this curve and you split it every 6 inches, and then you take the points and try to make the curve, the only thing I can tell you is you're going to have a different curve,
right,
than when you had it. But we don't see that anymore. Now it's like, here's the curve, here's the 3D shape. You figure out, like you use that data to figure out how your fabrication process can get to those points and that shape. And definitely we do see that it enables designers to be able to build those things that they can imagine. So
now
that's really
that
good.
Was the ending. That was great. Thank you so much for sharing this story today. This has been a lot of fun, and I learned a lot.
Well, thank you. So I really appreciate your time anytime.